So the first session, we're going to chat a bit about zero trust in non-IT environments. We'll look into the definition of what non-IT is. And so the agenda, if the clicker works. Doesn't seem to work, the clicker. Okay. Just want to keep it on time for you. That works?
Yeah, turn on.
Yeah. Thanks. So I guess that's the biggest learning. You should turn off things for them to start. So the agenda kind of this talk, and I'll keep it tight, is to do this introduction is IT, OT, IoT, what they are, talking a bit about network security and what we often see, as well as some solutions to implement zero trust in these environments and technical, practical steps to do so. So one example maybe to keep in mind through this talk is this ski resorts in the Alps. As you can maybe hear from my accent, I'm French, I grew up there. And so what we help this ski resort do is to empower that IT manager to deploy zero trust in a large infrastructure. They have 110 ski lifts that are just at the foot of the Mont Blanc, which is beautiful. And the main goal for him was really to reduce the network complexity that can scale quite fast, implementing better security postures as well as visibility. So maybe things that might be interesting as we move forward in this talk. So what do we call, or what do I call non-IT environment? It's a bit of a misnomer. IT is kind of eating the world. We have connectivity, we have compute pretty much everywhere nowadays. The idea is to say that you have a set of devices or a set of assets that sometimes we refer to as industrial controlled systems, operational technology, cameras, HVAC, and all that jazz, which are a bit different than IT, and so you should have different security protections for them. When we look into IT, a good EDR really provides a layer of protection that's really, really interesting. That's why we had seen so much evolution of the EDR, XDR, whatever fancy three-letter acronyms we want to put today in the last 10 years. And that really helps secure most of the endpoints that we have in the traditional IT endpoints that we have. There's definitely some caveats of having an external piece of code that has root access to your machine, but we can crack a few jokes on that. When we think about non-IT environments, it's way more difficult to deploy an EDR. And the three reasons there is that you often don't have access to the actual hardware. When you implement a camera, when you implement a KUKA robot machine, there's no way you're going to put a piece of code in there. The vendor is like, no, you just implement it the way it is. The second one is that they are systems that have been built with air gap in mind. They were not supposed to be connected or really with limited externalities. And so implementing an EDR and expecting basically to protect against a large set of behaviors was not how those systems have been defined. And this notion of, in OT, we often have to deal with a limited set of known behaviors. A machine is expected to do a limited set of things, versus a human in front of a computer can do a lot of unexpected things. We all know about that. So in the end, kind of the way to secure OT networks is really to put way more pressure or way more thinking in terms on the network versus on the endpoint. And that's why we think like zero trust, implementing zero trust starts with the network in OT environment. When we look into traditional network security, there is still this notion of moat and kind of peripheral security. Once you're inside the network, you're kind of trusted. That has started to change, especially in the IT world, with companies like Zscaler doing some really interesting work over there. In OT, it's most often not the case. We'll talk a bit about segmentation later on, but there is still this single point of failure, that's the firewall at the edge, and then once you're hit, there is a lot of problems that can happen. What we see also in terms of traditional network security is that managing the network, the size of the subnets, and how you group your assets can be challenging. We see sites that address in this large, like 16 or 24 kind of range, IP range, and so you have a lot of assets on the same topology. And then on the other side, if you want to get more granular and go to like /2830, it can quickly become a pain, especially when you start to move things around. So addressing and managing the subnet size can be a challenge. If you talk to network people, sometimes they complain about the performance bottleneck that you have. More devices are coming and more traffic is going through, and so you have this performance kind of pain point that comes along. And one of the key things that I think I want to discuss about is kind of we implement security both at the layer 2 and the layer 3 level with different mechanisms, and that's kind of when the machines start to grip and not work as intended or as well as it's supposed to. So this layer 2, layer 3 kind of differences is, I think, something that can be interesting to think about a bit deeper. What we see in terms of network is that this notion of east-west is slowly dying, and that most of the traffic is now moving into a north-south type of behavior. So north-south is you go external to a site, and why we say that is that most of the Office suite, for example, has moved to the cloud. You're using Google, you're using Microsoft 365, or so on. And so all of your IT mainly have an access north-south, versus before you had servers on-premise, and you were mostly looking at east-west traffic. There is still some cases where east-west traffic exists, and that's mostly operational technology. And so, but what we see is that there is this migration to the north-south with a small foothold of east-west that still lives in a way. So when we think about layer 2, layer 3, the right way, or what we think is the right way to look at this, is that layer 2 should be really dumb, fast, and simple. It's about pushing packets or data frame at the Ethernet layer as fast as you can without any logic to keep it simple. And then at the layer 3 is where really you can start to implement your logic, your routing, your visibility. And by really segmenting who does what, it kind of simplifies the paradigms that you're working with. So here's a really, really simple representation of that. The goal is to say layer 2, just build the network as simple as possible and plug the Ethernet cable together, and then try to bring all this connectivity to the layer 3 to do some analysis, to do some routing, and then you push it back down. When we kind of categorize things in this way, it helps later on to address the performance of the network as well as the security. One caveat that you could see with this architecture is that it creates a lot of headover and complexity in the calcul. The good part of this is that in 2024, the advances in compute, in storage, and so on makes it not a bottleneck anymore. And so having a lot of routing and logic that you apply at the layer 3 and packets moving up and down is not a problem anymore. I should look for the 2024 images in there. So if someone has that, I'm keen to get it. So with that said, I think if there is really one topic to take from this presentation is maybe the first one, is that we're a strong believer that VLAN should not be used for network segmentation. It's kind of a tool that was hacked around and that now we scale into network segmentation. It's mostly a bad idea. And the reason why is that or we can go through them. The first one is what I mentioned a bit at the beginning. By using both security and logic at the layer 2 and layer 3, you create a lot of complexity, risk of misconfiguration, and kind of the machines start to squeak in terms of performance of the network and who has access to what and so on. The second one that kind of ties into this is that most often you lack the visibility to understand what's going on at the layer 2. Analyzing data frame, you just don't know what IPs or what machines they kind of tied to, what protocol they're using at the higher level. And so it's really you're kind of playing with just blocks that don't make a lot of sense. The third point that also sometimes the misconception is that VLANs helps in terms of performance. The reality, and then if we go back to the ski resort I mentioned at the beginning, it's a small team, 30 people. They had 10 VLANs, and the average numbers of assets on a VLAN is 50. And so what you're actually doing is that you're putting 50 machines on the same LAN and that are sending packets together. When there's not necessarily a need for them, you're creating a VLAN with your cameras. There is no point for your camera to talk to each other. Yet with a VLAN, that's what they're doing. So by using kind of VLAN to group your asset and doing that logical segmentation, you in fact create a lot of performance bottleneck. That's going to be a problem down the line. One other thing is about, so when you start to play with more switches that scale across a network, you create trunk ports so that your VLAN can span across your building. And what that creates, in fact, is that you have like this really clogged highway of data that cross all your building, and that's taking a lot of load on the network and performance. And so one of the main things we try to do when we work with customers is kind of kill the trunks and reduce this highway, because it's mostly not necessary. Finally, VLAN is not great in terms of security. There is a lot of attacks, VLAN hopping, VLAN spoofing, that you can do pretty easily. And so there is this sense of like, well, I have VLAN, I have security. In most cases, it's not the case. So let's fight this, I think, preconceived idea a bit. Okay. So some people will say that, yeah, but you can do 802.1x, and that secures who has access to the LAN, and so on. Maybe a show of hands, is anyone has implemented 802.1x? Okay, we'll have to chat then later on. So it's a kind of an advance, or it's a protocol that was built 20 years ago, roughly a bit more, like 25, and that kind of hacked around how you could implement security on VLAN and layer 2, which was not really meant to be. But we had to do it at the time because you didn't have the compute capabilities to do that. Implementing 802.1x is a pretty long and painful endeavor. I will encourage you to talk to your colleague. And so really what we say is, please don't do that. That's today really a bad idea. There are solutions that are easier, unless you like pain, but that's a different topic. So yeah, there is different alternatives that you can do there. So as you can maybe hear, so far I'm pretty strongly opinionated about VLANs, how you should implement them, and so on. I'm not the only one. So Cisco, which knows a few things about switches and VLANs and so on, that's how they recommend, and it's pretty small, so I might read it, recommend to implement VLAN, is that VLAN should not span across multiple switches. So a VLAN should be just a switch, and it just be like those two ports need to talk to each other. That's it. And that was the intended definition of VLANs and how they were built. Yet we took that and said, like, well, we can span that across a network, and then we can group our assets and so on. And that's where like it's really misused nowadays and impacts performance in a bad way. So don't trust me, trust Cisco is maybe a second learning in there. Okay. So VLAN can have some interest, and this is the recommendation we usually give to companies, that you should have 2 VLANs. One that's going to be really for IT, and basically the way to think about VLAN, maybe to step back, is to say, how am I addressing and managing these assets in that part of my infrastructure? And the first one is to say, you use a VLAN that's for all of your IT, things that move around, things that you can throw in the trash and then spun up like a mobile phone or a desktop computer. And this is where you should have the HTTP, dynamic addressing, and kind of a network that's a bit more dynamic or flexible, knowing that here you will have an EDR presence that's stronger and that allows you to secure that part of the infrastructure. On the other side, you have another VLAN that's static, where it's everything that doesn't move, so all the rest, pretty much. The way to implement those VLANs is to implement them as private VLAN. What that means is that even though you are on the same VLAN, you cannot see your neighbors. So that's why sometimes it's called no neighbors, is that you cannot ping other machines on the LAN or in the VLAN. It's just it goes directly to the switch and the router at the head of your network. And this notion of private VLAN should be both in the 10 and in the 20, so in the IT and the OT. And it's at the top of the VLAN where you can implement routing to go back where it's needed and apply ACL and so on. So moving into kind of the zero trust principle, what that means, I think everyone pretty much knows about zero trust. It's been around for some time, but really it's this notion of never trust, always verify, least access privilege or ABAC in a way that kind of ties or dovetails nicely to it, and then this notion of continuous monitoring and verification. This is things that you can implement in OT, non-IT environment through scaling DMZ. So if you look back into the current status of the network, often you were putting a DMZ at the edge of the network, And that was kind of the buffer between the external untrusted and the trusted inside. With zero trust principle, everything becomes untrusted, and so the idea is how can I deploy a DMZ in front of each of my assets? A DMZ being a firewall and a proxy. The firewall gives you protection, the proxy gives you visibility. How do you scale this authentication bonds on the users and assets? There is a way to implement, especially when you are at the layer 3 authentication mechanism, both for the user with OAuth, LDAP, and so on, as well as with certificates. That's going to go up to the higher level layers, but that's something that you should implement to have a true zero trust environment. And then what you can also do is that by this firewall and proxy that's in front of each asset, you can really harden the type of behaviors they can do. So if you have a camera, as we mentioned, or a printer, they will use a certain port and a certain type of protocol. That's something that you can configure within your DMZ to be really specific to that device and having a hardened or minimal configuration for that piece of equipment. So this is this notion of micro DMZ. Sometimes we mention as demilitarized LAN, which is how for each asset I create this little buffer DMZ in front of the assets where I can do my authentication, my access control, my visibility. And it's not something that lives just at the edge like a typical DMZ and I lack visibility inside. It's something that I really bring to the edge in this notion of zero trust roadmap in a way. So to kind of look back is to say that at the end of the day, the way to secure this OT environment is to bring a DMZ, to bring IT in front of each of them. So it's kind of IT is OT, OT is IT, and so on. So it's a nice way to look at it. Yeah, so then when it comes to this DMZ, what's interesting is that you can put that in the hands of operation and ask them, like, what's the expected behaviors of that machine, of that piece of equipment? And from that, you can then build your access control list, your routing, and so on. And that's something that's driven by operation and not by IT to categorize your assets. So it's kind of, you take a different path that allows you to really reflect what are the needs for that specific asset in a way. And so, hope you have time, kind of doing an implementation recap of how you can implement zero trust in an IT, in OT environment. The first one is to say you implement 2 VLANs. So again, here there's a lot of simplification that you can do. Private VLAN if possible. One use DHCP and is dynamic, that's for IT. The rest is static, it's for OT environment. You simplify kind of the tools that you have by considering the layer 2 as a simple dumb layer that just moves the packets as fast as it can, when the layer 3 is about logic, is about routing, and so on. Routing decisions are based or are led by operation in this regard, which is how you really reflect, again, the topology or the needs of the network. And then setting DMZ, and this notion of demilitarized LAN, micro DMZ, wherever you want to call it, but trying to have this in front of your key assets so that you have a layer of protection from there. And then go fishing, as you can maybe hear from the name of the company, we're big fly fishing people. So we can chat about that also later. Yeah, and so maybe one last slide about what's next. So before starting this company, I was at Google X, and one of the first learning that we had to learn on the day one is don't try to predict the future. So everything I'm going to say after that is a bit taken with a pinch of salt. But the few things that we see, and I think going to continue, is that there is this IT-OT convergence. So more and more equipments are getting connected, how you secure them, and so on is going to become more relevant every year. Simplicity is kind of the North Star when you look at the network. Most often we have people that have been building networks and that don't really understand what's going on anymore because that has been passed along. And so having the ability to simplify, to abstract most of the kind of pipes is going to be really interesting to think about to scale. This notion of defense in depth and then zero trust, I think we're all really aware of that, but that's going to come to the less connected environment. that are often also the crown jewels of a given company. So that's something that's going to continue to grow. And the last one is maybe a hope, is that 802.1x is forgotten and long gone, but we'll see how fast that happens. And that's pretty much it, I believe. Yeah. So I don't know if there is any question. We have a couple of minutes.
Could you expand on your 802.1x? It sounds like you're not. 1 second.
I think they bring a mic.
Can you just expand on your comments on 802.1x? Someone raised their hand back there. I implemented it previously, so I'm just curious what your more opinion on 802.1x?
Yeah, so 802.1x aims to implement security at the layer 2. And so it's an old protocol that was invented in a period of time where you didn't have the compute capabilities to implement that at the layer 3, which is the right way to think about it. And so when you start to implement 802.1x, I don't know how long did it take you to implement it?
A long time.
Exactly. So that's why it's kind of like you're trying to fix a problem with the tool you had at the time, but nowadays with the evolution of compute, you can really keep the layer 2 as say like, I don't really care, it's just about performance, and layer 3 being security, authentications, and so on. So it's just an old protocol that was built in a different time, and that doesn't really apply anymore today. So that's why there's other ways to solve for this. Yep.
Thank you very much for the presentation. I enjoyed it very much, especially the quote from Cisco. I actually didn't know that. I was wondering, could you expand a little bit more on the choice to only have 2 VLANs, because that is a little bit against the grain of the general thinking that it's better to have more VLANs in general.
Yeah, I guess that's the whole presentation I did. So using VLAN for segmentation, network segmentation, is not the right tool. And the reason why is that you're actually building a LAN, you're building a cable that runs across all of the assets that you consider the same. But there is no reason for them to talk to each other. If you take the ski lift resort example, initially they had all their lifts on the same VLAN. There is no reason why the lifts should talk to each other. But it's just a way of, like, I structure things together and it makes sense. And so that's why, like, VLAN for segmentation is not the right way to do it. You should use subnets, you should IP layer tools, not VLANs. VLAN, or bridges, is also the same name, is really a bridge between 2 LAN, and to say, like, those 2 machines should talk to each other really fast. That's how it should be used. And so that's why, like, it's not using the right mechanism for what you want to do, which is at the end, I want to group my assets so I kind of understand the network, I can apply rules, and I can manage what's going on. Does that make sense a bit? Or?
Yes, that does. Thank you very much.
Okay. There's maybe one last question before I wrap up. I guess that's it. Thank you, everyone.